Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you?
Sir.
Okay, good. How are you? Everybody okay? Alright. Now before.
Waalaikumsalam, good sir.
Okay.
Yes, fine.
Okay. Before we start, any question, anything, any problem with the homework that I give you, the homework questions? Anything that you want to discuss? Okay. Okay. If there is no question, I hope everything is okay. I hope you have been doing the questions. Today, we're going to move on. We're going to do the last part of this chapter. That is on the application. So application of a system of linear function. That would be 1.6. Okay, 1.5 we already done. So 1.6 we are going to look at applications. Now there are two applications. The main application here. To look at the book 1.6. The first one is on the revenue cost. We are going to look at a model of break-even. So that's a break-even problem. That's the first one. Second one, we're going to look at the market equilibrium. So this is on economics. So market equilibrium, you have the demand function, the supply function, and then you have the market equilibrium where the demand and the supply function interact. So that would be our our focus today. So let's begin with the break-even. Now, what is break-even? As we know, break-even is what is break-even? If you have a business, you just break even. What does it mean? It means that your income, the revenue that you earn, just cover the cost. So that is break even. So number one, we are going to discuss about break even. So break even revenue just cover your cost. So for a business, whatever business that we are doing, you have the income, the revenue, cover cost, okay, the cost of operating the business. Okay, the cost of operating business. So that means what? That means your revenue is just equal to the cost. R is revenue, and the cost is C. So revenue just equal to the cost, and if you define profit, what is profit? Profit is equal to revenue minus cost. Okay, so when your break-even revenue equal to the cost, that means the profit is equal to zero. So break-even revenue just cover the cost. Revenue is equal to R. That means profit is zero. So when your profit is zero, R minus C is equal to zero. Then you will get R equal C. So that is break. Okay, revenue equal to the cost. Or, okay, R minus C equal to zero. Or we can just use profit. The profit is R minus C. So you can use these three things. Or, you know, at the end, it will P equal to zero, R equal to C, R minus C. So if you you start with R minus C, then that will lead to P, because P is R minus C. Okay, now we need what? You need the revenue. In order for you to get the profit, you need revenue, and of course, you need cost. Now, what is revenue? Denoted by R. How do you measure your income to your firm, to your business? The revenue. How do you, what is the revenue? That is the income that you earn. So how do you find revenue given the price of your product? Okay, given the price, call it P. Given the price, okay, let's say you are selling, you sell teh tarik, you know, and the price of the tea per cup is say 1 cent. So how do you measure your revenue given that price? How do you get your revenue?
Multiply by quantity.
You multiply by the quantity. So revenue is simply P times Q. Or we go by the book, X. Okay, we use X, where P is the price, okay, price, and then X is the quantity of the good. Okay, quantity in units, whatever the units are. Sometimes we use Q, sometimes we may use, sometimes you use X, sometimes we may use Q, okay, for quantity. We use X because X is the measure for the variable, label for the variable X. So we just use X. So for us, sometimes we use X, sometimes we use Q for the quantity. And this is the unit of the quantity, whatever the quantity is. For example, T, all right, T, we can say the units are in cups or in grams, whatever the units are. There are a few. And then the price, okay, the price P is, what is the unit? The unit is RM per unit of the good. When you say price $2, that means price per unit. We don't say, price $2. We just say price $2 mean what? Mean for 1 unit. Or you can use dollars per unit. Okay, all right. So that is revenue. Revenue is very simple, P times X. And given the price, so you have the revenue. So for our example, okay, revenue by selling T will be equal to P times X, that will be equal to 1.2. So that is your revenue. So revenue is just linear function, okay? So you see here a linear function, intercept is 0. There is no intercept. So meaning that if you don't sell anything, you will not get any revenue. Okay, all right. So that is revenue. So if you draw the revenue function, you will get something like this. Okay, so our revenue would be like, this is X, that is your revenue. Okay, so that's 0. And P is a constant. Okay, so P is given. Okay, so P given means P constant. So for example, you got 1.2. So therefore, in general, your revenue function will be just equal to something like this. Is that right or is that no? The revenue function that I sketched, is it right or is it wrong?
Wrong.
Wrong ke right?
It's wrong.
Saya pun lupa. Dah buat dah putih ingat. Sebenarnya salah lah sebabnya. Why? Because the B is 0. Okay, intercept is equal to 0. So it intercept at x equal to 0, y equal to 0. So that passed through the origin. So we draw again. What we did was wrong. Thank you. So here, revenue will be function going through the origin. So that is revenue equal to P. Now P is a constant, okay? P is a constant, and of course that P is bigger 0 mana the price negative. Okay, so P is positive. So you get upward sloping, okay? Upward sloping function. Example, if you draw 1.2, then you get the slope as equal to 1.2. Okay, correct. So that is the revenue. Okay, good. Everybody now mute. Okay, you mute. After that, if you want to say something, you will turn it on. Okay, so now we are going to look at the cost. What is cost? Now, when you look at cost, we have to go back to the economic concept of cost. Now, from your principles of micro, if you have taken principles, what are the components of cost? Denoted by C. Okay, economics. What are the components of cost that normally we describe cost in terms of? You have the fixed cost. You have the fixed cost. I start with the variable cost. You have the variable cost, and then you have the fixed cost. Fixed cost. The EDO. Okay, what is a fixed cost? Fixed cost. Short form VC plus FC. Okay, what is the fixed cost? Fixed cost is the cost that is the constant. Okay, so that is constant. So that cost do not change. Okay, with quantity. Don't vary or don't change with output level. Okay, with output or quantity. So in other words, it will be the same at each level of output. Okay, it will be same at all output level. So in other words, if you don't produce anything, output is equal to 0, you still incur the same cost, which is the fixed cost. And if you produce 1,000, you incur also that same cost. And if you produce 10, you also incur that same component of cost, which is fixed cost. Okay. Now, what is variable cost? Variable cost, on the other hand, is the cost that vary with the output level. Vary with output. So the more output we produce, the higher the variable cost. So that variable cost changes with output. Higher output, higher cost. You don't have higher output, lower cost, you know. So that cost will be always increasing. At the most, you know, will be stable, you know. But we just say variable cost increases with output. So let us denote the output or the quantity of the output. The quantity of the output, say X. Okay, just like the one that we are using for the revenue. So cost is a function of X. Okay, now go back to revenue. I should also say that, you know, we describe the cost function P equal to X, no, R equal to PX. We say that In fact, from our discussion here, revenue is a function of X. Okay, revenue is a function of X. Then we got revenue equal to X. So therefore, you draw the graph X on the horizontal axis, revenue on the vertical axis. Okay, all right, both are functions of X. Now, cost is a function of X. We denote that by f of X. And that consists of the variable cost plus the fixed cost. And fixed cost is a constant, which we already discussed. And that will be equal to, okay, look, now we use the notation in the book. What do they use? They use mx plus b. So that b is the fixed cost. Okay, the y-intercept. So in this case, the x-intercept, the c-intercept, that's the fixed cost. The one that changed with output, you call it variable cost, and that is equal to mx. So m here is the average variable cost. Average variable cost. Or variable cost per unit. Okay, variable cost per unit, same thing. So that is the m, that is the slope of the cost function. So you have these two components of cost. Now, in order to get some intuition, fixed cost, fixed cost. If you look at the cost, there are so revenue is easy, revenue you sell the output, you get revenue. Now, even though the cost is a function of X, but in order for us to get the idea of fixed cost and variable cost, you have to relate to the cost of the inputs. So they have to relate to the cost of inputs that we use in order to produce something. So relate to cost of inputs. In order for you to produce tea, okay, tea, you have to have some inputs, So generally in economics, you have the cost. Let's say tea ini kita fikir besar sikit lah. Let's say tea factory. Alright, tea factory like Bo tea. If you go to Cameron Highland, ada that Bo tea plantation, and in that plantation you will see the Bo tea factory. Suppose you have that factory. Now, what are the inputs? Of course, there are so many inputs. Now, what are the fixed costs? Give me example of the fixed cost. In other words, if the factory doesn't work, okay, if the factory do not produce any tea, you still have to incur that cost.
Rent.
That's the fixed cost. Apa dah?
Rent.
That's the rent. Okay, the rental to your machine, all right, to the equipment. So you still have to pay that, or the rent to the land. Okay, so this one is the fixed cost, your equipment cost. Normally, this kind of cost, the fixed cost. Variable cost is the one that you can easily dispose. So you don't produce, you stop the output. So one good example of a variable cost is the labor. Okay, labor. So labor is easy to dispose, easy to hire, easy to dispose. So labor is a good example of a variable. So that is the idea. Okay, so you will see here the cost is equal to mx plus b. Example, let's say I have C is equal to 0.9x plus 200. So 200 is our fixed cost, 0.9 is the slope of the cost function, that is the average variable cost. when you draw the graph, okay, you have C as a function of X. So we can draw it on the same graph. So you got here R, and then you put C. Okay, C, somewhere. The units are the same. The units for revenue is in terms of RM or dollars, whatever the monetary unit that you have, rupiah, you know, or rupee, murah. PKP ni tak tengok. Duit Arab Saudi, kita panggil apa? Rial. Or you can use rial. Okay. So here, same thing. Cost in terms of dollars, RM, etc. It's just the money. So if you draw the graph for the cost, the intercept will be positive, somewhere there, B. All right. And then you get something like that. So that is cost. So cost will be equal to something like this. And of course, we assume that the B is positive. Okay. M is also positive. Fixed cost. So all costs are positive. So we go back to our example. Let's say this is 1.2x, and the cost is mx plus b. We use the example 0.9x plus 200. So that is our cost. Now, as you can see here, that is the point of intersection. Okay, so this is what you call the break-even point. That is the point at E. Your revenue is just equal to the cost. Profit is 0, right? So at point E, so break even. What is our condition for break even? Profit equal to 0, okay, which is equal to R minus C equal to 0, or R equal C. So R equal C is that diagram. You have the revenue function, you have the cost function, R equal to C. So the equilibrium occur break even at where? At P equal to 0. So what you have? You have the break-even point or equilibrium. So the break-even point, okay, denoted by E, and that point E will give you what? Will give us the quantity X star. So X star here is called the break-even quantity. So at point E, I have break-even quantity. Break-even quantity. Break-even quantity, we call it X star. And then that will correspond to the break-even revenue. Call it R star, and that must be equal to the break-even cost, C star. So break-even quantity, X star, and then I have the break-even revenue, cost, and revenue. Okay. C star equal to R star. So that is our break-even point. Okay. So break-even point, X star, C star, which is equal to R star. Okay. Any question? All right, good. So the intersection point would be the break-even. That is where the revenue equal to C. You will get the output level, and you get the equilibrium revenue and the equilibrium cost that will cause the break-even. They must be equal. So therefore, we already have this example here. All right. So I want you to solve the system. So what you have is, a system of equations. So here you have a system of linear function. So you can solve it. Right? So I want you to solve. Find the equilibrium point. What is the break-even output level? And what is the break-even revenue? Okay. Okay, buat sekarang. This one should be very easy lah. Okay. I see here there are many people lagi yang belum letak gambar. So bila nak letak gambar ni? Saya dah cakap dah 2 minggu lepas dah. So please, for those people who still have your pictures missing, ni tak nak gambar ni, what it for? Can you take a picture satu selfie tak kira lah, without that mask? Okay. Ramai lagi tak buat gambar ni. So please, okay, I want to see the pictures by next week. Kan ni susah sangat pun. Okay. Alright. Good. Okay. Who? Are you here? Who? Don't put the X. Okay. Put your picture, your own picture. Alright. Don't put the X. Ni siapa pula ni? Ini Spiderman ke apa ni? Who is this guy? Ni. S100, 200, 211, 209 ni apa benda ni? Do you have a name? I don't want to see the code. If you are a special agent, I don't think you qualify to be in this class. Ada pula guna code ni. Apa? You bagi nama cantik pakai code. Okay. One more thing. Okay, one more thing. Here I have 65 people. Last time I got 68. I mean maybe 3 is missing. I got about 65 to 68. Now in the class list, section 7, section 8, the list that I received was first week of class. So I'm sure a few people have added the cost, and there are 1 or 2 drop the cost. So I would like you to check your name list. If your name list is not in the original list, okay, can you tell me that you are new? Give me your name. Tell me the time, not the time, the date where you register for the course. And of course, you do it in the section that you are in. So you use the WhatsApp group. Okay, use the WhatsApp group. Then you tell me your name, and then when did you register. If you are new, okay, you're new, that means you registered during the second week, or your name is already in the list, because my list is full list, so I will get a new list later on. So if you are new students, you put down your name, your number, of course the section, but you don't have to mention the section because you do it in the WhatsApp group, the section, and then the date where you register. So this one you do in WhatsApp, okay, so that I can have information who are the new students. So when I look at this, all right, I can add your name, okay, I can add your name to the list. And I know there are a few people who are new because of this number. Our original number was not this high. Okay, clear? Is that clear? Okay. So on that microphone, if it is not clear, you on the phone say it's clear. If it is not clear, tell me that it's not clear, then I can repeat myself. So that, tak payahlah saya cakap 3 kali. Okay, ni I have to make announcement 3 kali. Sometimes we don't understand. So I want to make it clear. Okay, so go back to the example. What is the break-even quantity? Anybody who got it? The first person who get it, let me know. Hello?
666.667.
Yeah, semua dapat 6. 6.667. Okay. So that X is 6.667. Okay. Now you put into the cost or you put into the revenue, you should get them equal. Even though they are not, sometimes it's not equal because, of the decimal points. But it should be very, very close. Okay, it should be very close because that is the point where it intersects. Okay, everybody got it? Okay, good. So that is a very simple example where we make use of a system of linear functions to find the break-even point. So what you did was, revenue is equal to 1.2x, call it number 1. Cost is equal to 0.9x plus 200. Betul tak?
Yes.
So for break-even, what is the condition? So for break-even, you have revenue equal to C, or R minus C equal to 0. All right? So R equal to C. So therefore, you have 1.2x equal to 0.9x plus 200. So you bring the x to the left. So I have 1.2x minus 0.9x equal to 200. You simplify that. Kita dapat work this out. Okay, you got x star equal to 6.667. So everybody should get it. If you don't, okay, go home. Okay, look at the condition here. That's the condition. And then you equate the revenue to the cost, work it out, you got this. Okay. All right. Now to get the revenue and the cost, what you do, you put the X. So next would be substitute X star equal to 6.667 into either R or cost. Doesn't matter. All right. To get what? To get the break-even revenue or cost. So let's say we put it into what? Into R. So we got R star equal to 1.2667. Or you can put the cost. Okay, or you can put cost. Or you can do both. Okay, to make sure that they are equal. All right. Now, if you do that, what do you get for the R star?
$800.004.
800.005. Ataupun ataupun you just make it 800. Okay. All right. So the cost you might get about the same. So that is the break-even revenue. So you conclude, okay, when you do application, you have to describe your answer. When you do the regular question, you don't have to describe. So here you have to describe. So we can say that the break-even quantity, okay, the break-even quantity is to break even. Make it, okay. To break even, we have to sell 6.67 units of tea. Okay, if I say cups of tea, betul jawapan kita ni. Apa? Price is 1.2. You know, if you have 1.2 multiply.
X6. The X is 666.667.
Kalau 6.67 multiply by 1.2, you don't get 800.
666.
Apa saya cakap tadi, I tell you, you want to say something, janganlah mute mic. Oh, somebody on the microphone. Cakap lah, ini saya dah penat dah. Saya dah letak semua main diam. Susah lah macam ni. Okay. I tell you, you don't have to mute your phone. As long as you keep quiet and you talk when it's necessary. If you mute, if you want to say something, on je lah. Susah. Okay. So you mute, that's good. But when you want to say something, on je lah. So dah salah dah kena saya kena patah balik. So semua main diam, susah. Okay, berapa tadi? 6.66. Ni, betul ni. 666.67.
67.
Semua main pakai diam, susah. Okay. Kita ada 60 orang, jangan semua pakai diam. Seorang cakap lah. Ini, kalau saya tak terfikir tadi, saya main tam je tu. Habis, sampai ke habis lah salah. Okay. Saya terfikir, revenue 800. Again, quantity 6.67, the price is 2. Doesn't make sense. Everybody keep quiet. It's easy to keep quiet, But pay attention, lah. Right? I need only a few people. I don't need everybody. So a few people have to be more attentive. Okay? So that benda-benda macam ni terjadilah selalu. So you have actually 666.67. Betul? Okay, 666.67. So you have to sell 666.67. If you say the units of cup, and the break-even revenue and cost is 800 RM. Okay, 800 RM lah, 04. Tak payah tulis 004. Okay, betul ya? Any mistakes ni? Betul 800?
Betul.
Yes.
Alright. Okay, that's it. 600. Something multiplied by 1. Okay, so here is the break-even example. Now you will get an equilibrium here as long as your price, okay, the price of your product is larger than your average variable cost. Okay. If you have your price larger than the slope of the cost function, that is the average variable cost, so there will be an equilibrium. So you get equilibrium at x bigger than 0 or 0. Your P must be bigger or equal to that slope of the cost function. Okay. All right. Okay, now, cuba draw. Okay, I want you to just try sketch. You draw a diagram or sketch a diagram where the M, here you got MX plus B. All right. And then you got the R equal to PX. This one is your average variable cost. Okay, now I want you to sketch. If I draw a sketch, you just get the graph. You just sketch the line. Suppose I have M bigger than P. right? If you draw it, M is bigger than that P. How is the solution? Because I tell you earlier, for you to have the equilibrium X bigger than 0, the slope of the revenue must be larger than the slope of the cost function. So now, you draw on the same graph, you draw it, the M is larger than the P. What happened? Okay. How is your diagram? If you have the slope of the cost function steeper than the slope of the revenue function, apa dah? What happened? Is there a solution?
No.
There will be no solution. But there is a solution actually, but that solution is not valid. Where is that solution? If you sketch the line, you extend it downward. What can you see? Solution.
When y-intercept is negative.
Negative. Okay, everything will be negative. You got the intercept will be at the negative values of the x and y. So that's why you say, okay, there will be no solution, because what you want is a solution for us, the x and y, or the revenue and the cost, and the output level must be positive. So if you have that kind of situation, you will have the intersection way down there, all right, negative x. So it will not be valid. So for applications, all right, we want the x to be positive. So for application, this is general, it's not just for this part. You have the x and y, so this is general. For application, what you interested is will be x, y are all positive. So we need only the first quadrant. So if you remember, when you draw a graph, there are 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. So we only deal with this one, okay, for application. You will need x positive, y also positive, all right? Because when you are dealing with application, for example, revenue, the quantity, there is no such thing of a negative quantity, right? Quantity must be always positive. Same thing, revenue. Revenue is either 0 or larger. Same thing with cost, okay? So for application, we did only with that quadrant. The second quadrant, third quadrant is not relevant. When you draw the graph for application, actually we can save a little bit of time because we only need to focus here. Okay, even for me here, I draw a little bit more, toward the negative x. But I should have something like this, you can draw a little bit, itu boleh lah, tak tunjukkan negatif. Okay, so our focus will be on the positive part. Okay, all right. Any comment, any question, anything? Okay, all right. So we are done with the ni. Oh, ada lagi konsep. Konsep lagi. So the other, yeah.
Can you show us how to draw the graph calculation just now? Yang break-even point revenue dia itu.
I want you to draw, not me draw.
So, I tak dapat lah.
Tak dapat balik rumah, cuba lagi sekali.
Okay, sure.
Cuba
Okay, sure.
hari Wednesday tak dapat, baru beritahu saya.
Alright.
Yeah, well, it's just like this. You go back to this example. Here, I have what? I have the slope of the revenue steeper than the slope of the cost. Okay. So what you want to do for the example tadi tu, you have the revenue. Okay, but now you make the slope of the cost steeper than the slope of the revenue. Okay, steeper. Mana ya, bukan macam ni lah, steeper. So go home, try. Alright. If you cannot do it, Wednesday I withdraw my record. So balik bincang, bincang kawan-kawan tu. Okay. Alright, good. So that's where you know we have our discussion. Okay, there are a few things that I need to discuss. This one, the concept of the slope. So here, you know, the slope of the revenue and the slope of the cost. All right, now you look at the revenue, R equal to PX. The slope of the marginal, the slope of the revenue function, slope of R is equal to, slope of R is equal to P. All right, equal to what? Equal to delta R over delta X. So delta R over delta X, that is the P. Okay, P is the change in revenue. I'm giving the general concept, the change in revenue for a unit in quantity. So P, okay, P is the slope, P is the price. So P is the change in revenue for a unit increase in the quantity sold. So here I have already the price increases by 1 unit. I'm sorry, not the price, the quantity X. And we have price positive. Okay, price positive. There is no such thing as price negative. Okay, or you can put here P equal to 0, but P equal to 0 or revenue is 0. So for positive price, then which direction is the change in revenue?
Increase.
Increase. Okay. So the price is the increase in revenue for a unit increase in quantity sold. Or we can say here, for a unit increase in quantity sold, the increase in revenue, or we say revenue increases. By how much? Revenue increases by P. Okay. Now this is called the change in revenue per unit increase in X. Per unit increase in X. Or in more general, the change in revenue per unit change. I can put here change. Okay, before per unit change in the quantity sold, that is called the marginal revenue. Okay, so for our example, the price is equal to 1.2, right? So for what? For a unit increase, for that unit, for our example is cup. So for cup increase, for a cup increase in tea sold, what about revenue? Revenue will increase by how much? By RM 1 point. So you sell another cup of tea, your revenue will go up by 1.2 ringgit. And that additional revenue is just equal to what? Equal to price. Okay, 1.2. 1.2 is the price. So the marginal revenue is just equal to the price. So for this example, our MR is just equal to the price. MR, marginal revenue. Okay, I should put that, marginal revenue. Okay, any question? So that is the slope. Okay, that's the slope. The slope of the revenue, we call it marginal revenue. How is it measured? Delta R over delta X. So that price, which is the slope, is the change in revenue for a unit change in quantity sold. In terms of an increase of X, we say it's the what? It's the increase in revenue for a unit increase in quantity sold. And it is what it is P. So the price is the marginal revenue. Okay, all right. So that's marginal revenue, and that's how we describe it. Okay, so there is a two different things. One is the meaning. Okay, the meaning of what do you call it? The concept. The marginal revenue is the price. That is by definition. How do you describe it? Okay, describe it in terms of the increase. Okay, the increase in revenue for unit increase in quantity. So that is how we describe the marginal revenue. Okay, any question, any comment? Okay, all right, good. So let's look at the other concept, which is the marginal cost. Okay, marginal cost. Marginal cost, we denote that by MC. So if you look at the marginal cost, that is the slope of the cost function, delta C over delta X. So that is equal to M lah tadi, okay? M is the marginal cost, which is delta C over delta X. And that is the slope. Okay, marginal cost, MC, is the slope of the cost function, which is M, and we call it marginal cost. And of course, by definition, it's the delta C over delta X. Now, if you question how you got delta C over delta X, you will have to go back to our original notation. You have cost function of X. All right, so therefore, the slope is delta C over delta X. All right. So here, M is the change in cost, all right, for a unit, we start with change, for unit change in quantity. Quantity produced. Because cost is produced. Revenue is you sell. Right? So we go into more specific. We want to say a unit increase. Okay, a unit increase in X, in what we produce. And since M here is positive, what is the change in the cost for a unit increase in quantity produced? How is the cost changing? Increase or decrease?
Increase.
Increase lah. Okay, so for a unit increase in quantity produced, the slope M is the increase in the cost. All right, so that is our concept. So the example, when M is equal to 0.9, all right, so that is marginal cost. That's the slope. So 0.9 is the increase in the cost for a unit increase in quantity produced. In other words, for a unit increase in quantity produced, I write down picture. In quantity produced. What about the cost? Cost will increase by how much? By RM 0.9. So for a 1 unit quantity increase, for a 1 unit increase in production, in quantity produced, the cost will increase by how much? 0.9 ringgit. So that is the increase in cost. So the increase in the cost for a unit increase in output level, we call it marginal. So it's not easy, it's not difficult to see, you know, for economics, in economics, the slope, okay, the slope of other functions, slope of any functions, okay, not most function, not any, most function in economics, they call it marginal. Marginal, the name of the function. You've got revenue, the slope of revenue, you call it marginal revenue. Cost, the slope of cost, you call it marginal. So marginal means what? Marginal means change, a small change. So that is the slope. And other functions, you know, consumption, you call it marginal consumption. Things like that. Okay, any question, anything? So for this break even, I would like you to do some questions. All right. I think we already did the question. So break even 1.6. I would like you to do question number. Okay, question number 1. You can do 1. One, two, three, 4. So I would like you to do from question from number 1 to number 4. You don't have to do all, you know, do 1 or 2. And then you do number 6. Okay, so the break even are also number 7. Okay, the break even you buat number 18, 19, 24. 19, 24. Right. So those are the break even. So now we move on to the second part. Now the second part is the market equilibrium. Second part, market equilibrium, this is on economics. This is a model of demand supply. Okay, demand supply model. Demand supply model. So when you have a demand function, you have supply function. You know, you have a market. Then there will be market equilibrium. So if you look at the market, any market, say a market of a good, for example, the tea again, okay, tea in cups. So the one that we were talking about, the revenue side, okay, the revenue side tadi itu is the supply. Okay, supply means the sellers, or the sellers, the firms. Sometimes you call it firms. Okay, the sellers, the firm that sell tea. The demand side would be what? Would be the consumers, the people who demand tea. Okay, consumers, they are the one who demand tea. They want tea. Okay, so you have the consumers, you have the sellers. They interact in the market. They will determine the market equilibrium. All right. Now, what do you mean by market equilibrium? Market equilibrium, the interaction between the demand and the supply, consumers and the sellers, will determine the market price, and also will determine the market quantity. Both lah. Or sometimes you call it equilibrium. EQM itu maknanya equilibrium lah. Equilibrium price and quantity. Okay. Now, when you look at the demand and the supply, and you look at the market, in order for you to determine the market equilibrium, we have to have understanding on the demand function, and we also need to understand the supply function. Okay, all right. So, what is the demand function? Demand function, what is it? Tell me what you know about demand function. Okay, apa demand function? What is the demand function? Or what is demand? Demand function. Okay, demand function. This is what? This is on the consumers. Okay, and it relate what? Relate the price of the good to the quantity, to the different quantities, to the different quantity, different quantity or different quantities, different quantities, different quantity. Different quantity. Right. So relate price to different quantity. So in other words, the price, consumers, the consumer price, okay, the price consumers willing to pay for different quantity. So you have P as a function of X, where X is the quantity in units, P is the price. All right, in RM per unit, or whatever the unit is, dollar per RM pun boleh lah. I'm sorry, dollar per unit or RM per unit. So you have price as a function of quantity. Okay, now you are a consumer. All right, you are a consumer. Sometimes, you know, how do the price relate to the quantity for the consumer? Suppose there are so many durian in the market. Okay, too much durian. Everybody, every state produce durian. You know, what happened to the price of durian?
Decrease.
Decrease.
Decrease lah kan? So just like that, the demand meaning, if there are so much quantity, you makan pun dah tak nak lah duit tu. Kan? So that means you are not willing to pay high price anymore. So the price will go down. So the demand, if the X is too much, then you are willing to pay low price. Sometimes it can work either way, for demand function sometimes. Okay, this is the fact, all right? The fact is that sometimes it can work the other way around. Sometimes when the price increases, if the price of a good is too high, what about the demand? What about you? Are you willing to buy that good?
No.
No. So
Oh.
X decreases. So demand function can work either way. Either you have X as a function of P, okay, X a function of P. Apa saya ni? Mana pergi? Dah habis. X function of P. Dah habis. X a function of P. It can be X as a function of P. Boleh tak? Okay, either way. So I call it fact. It can be X increases, the price will go down, or prices increases, quantity will go down. So we follow the book. Okay, we follow the book. So that you have a consistent diagram. So we follow the book. We write function in terms of what? X. In other words, P as a function of X. So when the quantity increases, the price will go down. So you have what? You have the demand function downward sloping. So when you say demand function downward sloping, you have P equal to F of X. Suppose the demand function, I can say, oh ni dia pakai Q pula kat sini. Buku ni pun pening tak? Sekali X, sekali Q. So kita guna Q. Okay, I would like to be consistent dengan buku ni. For the quantity, for demand supply, they use Q. So kita guna Q. Nak guna X juga. Tapi kalau nanti kita pening, bukan pening, tend to be confusing. Kita guna X, Q. Okay. So you got Q here. Ini semua jadi Q. Q. Kita pakai buku lah, saya ingat. So P as a function of Q, where Q is the quantity. Okay, so P as a function of Q, Q is the quantity, P is the price. And let's say you got M, Q plus B. So M is the slope. So for the demand function, you have this relationship. The slope is negative and B is positive. So the demand function, all right, which is very important, the slope is negative. Okay, all right. Now you look at the supply function. Supply function is the firm. Okay, are you finished? Yeah, are you done?
Yes.
All right, good. So supply function, supply, it is the firm. All right, firm, selling. Now, when you sell the good, sometimes when you sell the good, suppose you produce too much. Quantity ni too much, macam tu tadi lah. Quantity too high. Macam supply ni, sometimes kita guna ini lagi senang. To get the idea, sometimes kita relate price lagi senang. So let's say you start with the price. suppose the price of tea increase, or a higher price. Tea now becomes 3 ringgit. Okay, 3 ringgit. Market price tea daripada 1.2 ringgit becomes 3. Because kopi apa banjir tak jadi, kapal jatuh, kopi tak datang. So in the market there is only tea. The price of tea go up. So if you are a seller, what about the quantity of tea that you want to sell? Not that you sell, you want to sell.
Increase.
If the price is up, the sellers want to sell more. Okay. Or if the quantity is high, you want the higher price. So kita tengok macam ni lagi senang. Alright. You have, if the quantity is increasing, you want to sell more. It's not that clear. You can see it clearer if you want to relate the price to the quantity. So conversely, if the quantity is higher, you got the price also increases. So we're going to specify the supply function, P as a function of Q. All right, so you got Q increases, P increases, and that will be equal to NQ plus D, where D is constant, N is the slope. So N here is positive. So for the demand function, for the supply function, the slope is positive. Okay, D is a constant. Now for the D for supply function, this one can be positive, sometimes it can be also negative, depending on the situation. So the D is not that important. Okay, the one is more important is this one. So you have a supply upward sloping, demand downward sloping, where we specify it P as a function of Q. So therefore, when you draw the graph, okay, when you draw the graph, you will do it this way. You draw Q on the horizontal axis, P vertical axis, because we specify P as a function of Q. Okay, all right. Now, having said that, like I said earlier, it's a fact that we can also write the supply function Q as a function of P. Okay, this is perfectly okay. Okay, it's perfectly okay. Because here, you see, when the price goes up, quantity goes up. So Q as a function of P. But, okay, we will start with this one. We just, to be consistent with the book. Okay, all right. So you have the demand function, supply function. So the demand function will slope downward, be like that. Call it D, demand function. And then you have the supply function, sloping upward. We call it S. And then there will be the equilibrium point. That is where the demand supply intersect. So here you have a market of T. Okay, market is only for one good, not the market for the whole country. Of course, the market for the country boleh juga, but for one good. So this market can be local market of tea in Gombak, okay, market of tea in Ipoh, market of tea in Malaysia, or market of tea in Kuching. It doesn't matter. So you have a market of tea in Mecca, all right? So you have a market of tea or market of one good. Can be tea, can be computers, can be cars. So the interaction between the supply and demand, you will determine equilibrium. So I have a Q star P star. Okay. All right. So for market equilibrium, I have here. Okay, for market equilibrium, condition will be demand equal supply. The demand function intersect with the supply function. And the equilibrium would be equilibrium quantity. Call it Q star. And then we also sometimes call it market. Okay, market or equilibrium quantity. Or you have the equilibrium price. Call it P star. Or sometimes we call it market. So market quantity or market price is the same as equilibrium quantity, equilibrium price. So the interaction between the consumers and the firms, you get the market equilibrium. So that is equilibrium. Okay, so all these functions are what you call it, are linear. Okay, are linear functions. Then you will just solve for the equilibrium. Okay, let's look at example number 4. So go to example number 4 in the book. Okay, 1.6, go to example number 4. Oh, my book is on page 107. Maybe another edition. Okay, I want you to look at that problem, not a problem, that example. And just go through it and see how we get the equilibrium. Okay, kita lihat dapat equilibrium tu. How do you get that equilibrium? Okay, what is the method to get that equilibrium?
Demand equal to supply.
Demand equal supply. Okay, so you put there, okay, for market equilibrium, how to solve the problem, you start with this one. For market equilibrium, that's number 1. For market equilibrium, that's number 1. Number 2, demand equal supply. Okay, so you have to have Nila, because if you look at that example, at market equilibrium, demand equal supply. Okay, demand equal supply, then what? Then you substitute. Okay, substitute one into the other. One into the other. So what do you want to substitute? Either way. All right. So here, if you look at the book, they substitute the demand into the supply. All right. You are given demand P equal to negative 3Q plus 36. And then you are given the supply P equal to 4Q plus 1. You substitute demand into the supply. So therefore, what we get will be what? The P, okay, which is negative 3Q plus 36. That is equal to the supply, which is 4Q plus 1. So you solve that, you get Q. Q equal to 5. Okay, that is example number 4. Now, once you get Q equal to 5, what we do next is that we want to find P. To find P, what do? Substitute Q equal to 5 into what? Into D or S, doesn't matter. So if you look at the book, they didn't do anything. Okay, they just give you the price. So that is, we don't want shortcut. Okay? We want the long cut. You want to show how you get the answer. So now, I want some people, okay, if your name is from A to M, okay, your first name, you put into D. If your name from N up to Z, you put into S. Either way, we should get P equal to 21. Okay, wait now. Substitute. Okay, substitute, show the work. We should get 21. Okay, dapat 21. For those people
Dapat.
who substitute
Yes.
21. Dapat? Dapat ya? Substitute supply dapat kau?
Yes, sir.
Okay. Good. All right. So we have to do the substitution. Okay. Don't just give the answer like the book. The book will just give the answer because they want us to do the extra work. Okay. So we have to find it. So that's good. So I think I'm going to stop here because some people have class at 11:30. Next class on Monday, we're going to move on to the second topic. But I need to finish up the example number 5. So we will continue a little bit more on this in this topic, market equilibrium. After that, we'll go on to the topic number 2, linear programming. So we're going to finish up the market equilibrium. Okay, for the next time. And then we're going to move on to the inequalities. So if you have time, you can tengoklah inequality itu. Wednesday kita bincang. Okay, all right. Any question? Anything? Okay, now I have one announcement. Kalau for our homework, our assignment, our test, everything, we'll make use of classroom. So I will, in the near future, we will generate this classroom group, or we will form the classroom group according to. So I will, we will do that. When I assign you the first homework, by then I need to, or I have to form the classroom group. Okay, the classroom group will be based on your section. Okay, that is just an announcement. But I'm not sure when. I hope we can do it by next week. All right. Okay. So I'll see you again. Have a nice study. Have a nice time study. I'll see you again on Wednesday. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Have a good day too, sir. Thank you.
Thank you.
Waalaikum.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.
Thank you.
Thank you, sir.